Okay. Well, we've done this one, but I've done it a couple of times. Okay, so this is number 5. And it's kind of interesting the way this works out. Okay, now note that the slash means here's your numerator, here's your denominator, right? So write down what you think this thing would be. Okay, so once again, people did quite well with this. Okay, about half the class nailed it, and the other half of the class almost nailed it. And then when I said not quite, they nailed it. Okay, so that's very good. Okay, well, let's decompose it. Okay, 1 slash quantity x plus 6 means, no, let's just take the first one. It goes in the top, and then this goes in the bottom, right? Well, let's write it out. Let's write the bottom down still in the common typewriter notation. And incidentally, if you want to write down this thing into a computer algebra system, this is how you have to write it. Okay? If you want to type it into Wolfram Alpha or anything else, to, you know, because at some point, like if you're trying to factor a 4th degree polynomial, in general, you better have a computer algebra system handy. There's strategies you can use, rational roots theorems and all that stuff. Okay, but usually doesn't work. Okay, so you got to understand how to type into a computer, but if you can do this, you can figure out all the rest. It's just order of operations. Okay. Okay, so you got 1 over the quantity, 1 over, okay, well, that's good, but of course that means then 1 over 1 slash x plus 6 means 1 over x plus 6, right? Okay. Now we want to simplify that because this isn't a simple fraction. This is a complex fraction. It's a fraction of a fraction, right? What's this mean? I'll let you tell me what this means by writing it down. Just going to give you about a minute. You'll either see it or you won't. But when I tell you, you will. Okay, well, you have 1 divided by a fraction, right? So this means one divided by 1 over x plus 6. What's 1 divided by 1 over x plus 6? 1 divided by 1 over x plus 6. By your rule for division of fractions is 1 times x plus 6 over 1. Okay. Now, 1 times anything is that anything. 1 times x plus 6 over 1 equals x plus 6 over 1. But of course, dividing by 1, dividing x plus 6 by 1 just gives you x plus 6. Now, the point of this problem is you have to know what it means to divide a fraction. First of all, you have to follow the order of operations to write this down, which will help you a lot when you need to put things into a computer. Okay? And then you have to know that this is a division, 1 divided by this, okay? Which means 1 divided by this is 1 multiplied by the reciprocal, okay? And that gets back to your rules of fractions, which you need to practice and need to be kind of second nature. You also have to remember it, okay? So it's one of those things you put on your list of things that you absolutely have to remember. To divide by a fraction, you multiply by its reciprocal. Write that out in words, write that out in symbols, review it daily until you're dreaming about it. Okay. Okay. And the way problem 13 is posed, this is really completing the square, but it's making sense of completing the square rather than following a bunch of rules for completing the square. So I'm going to talk about why it makes sense, which should help understand the rules, and the rules are presented perfectly well in your open math or in your textbook or whatever. Okay, and I might work on the rules since some of you are going to probably encounter this on the final. But I prefer to start with what it means rather than give you a bunch of rules that you never make sense of. Then you have your choice. Memorize the rules and follow them, or understand what it is. And different people make different choices in that. You know, your bottom line is to be able to complete a square. Okay. Okay, so what this means is, okay, if you square x plus h, you get x squared plus 2hx plus h squared. Now that's by the distributive law. Use the distributive law. There's a formula you can memorize for the square of a binomial, and it's okay to memorize that, but know where it comes from. Always be able to use the distributive law so that you don't think that the square of this is just x squared plus h squared. As we saw last time, function notation doesn't distribute over addition, okay? Neither does square. Multiplication distributes over addition. Nothing else does, okay? Except maybe function notation if you happen to have linear functions, but don't worry about that as a confusion. Unless you can prove it. Okay, so anyhow, so we could. Maybe all of you could. Okay, so x plus h squared is this. So can we match this up with this? Okay. Now, it doesn't match up because you don't have a number out here. H squared is just going to be a number, right? And h is just going to be a number. Well, can you determine if this is the first part of this, then what's your value of h? Now, ignore the h squared. Just tell me what h has to be to make this equal to this. Yeah, it's got to be 5, doesn't it? Yeah, let's look at it. Oh man, I didn't record any of that. That was terrible. Blame it. That was so good. I probably would have won a Fields Medal for that if it got loose. Oh, agony. Okay, well, I'll go over it. Okay. It'll be a little faster than it was, and you're going to be able to see what's coming, but okay. I don't know. Obviously, I'm not tuned in to the technology. I don't know, I've been doing it for a long time. It's kind of automatic. You know, things automatic, and sometimes I screw it up. Okay, x squared plus 10x is the first part of x plus h quantity squared. Okay, that's your problem. What's h? Well, if you square x plus h, you get this. Okay, use the distributive law. Don't try to memorize the formula, or by all means, memorize the formula, but always be able to verify using the distributive law. Because you're going to remember the formula wrong. A lot of people think that If you square x plus h, you get x squared plus h squared. Terrible, terrible mistake. You're dead in the water as soon as you make that one, okay? Distributive law says otherwise, okay? And the idea that multiplication distributes over addition. Squaring doesn't distribute over addition, as this proves, if you use the distributive law, okay? Function notation doesn't distribute over addition. We saw that last time. Almost nothing distributes over addition except multiplication. Or if you wish division, that's just multiplication by a reciprocal, okay? So it's just another instance of multiplication. Okay. So anyhow, we got this. Now, we say that the first part, this is the first part of this. By the first part, what do I mean? Well, if you look at this, you see that your x squared is there, right? And you got an x term there, okay? Now, the 10 is in front of x here, and the 2h is in front of x here. That means that your 2h is going to be 10. There's no h squared up here, but that's okay. The fact that the 2h is equal to 10 is enough to tell you what h is, and then you got to tack the h squared on. Okay, so, well, that means we've got to match this expression with this expression. That's just what I said. You got the x squared. The 10 clearly has to be your 2h, because this is the only x term, and this is the only x term. Okay, and you don't have an h squared here, so you're going to have one. You're going to have to do something about that. That doesn't prevent you from figuring out what h is. It's got to be 5, because 10h, or 2h has to equal 10. So 2hx got to be 10x. So 2h is 10, thus h is 5. Now, I think I said earlier, there are step-by-step procedures for completing the square, okay? This is why completing the square works. If you understand this, then even if you forget the step-by-step procedures, you can get there, okay? If this is easier to understand, or if it's easier to both memorize the steps and understand where they come from, then that's even better for you because you retain it better long-term. And if you got more math in your future, especially through a calculus course, you're going to have to complete the square, okay? And there are places in pre-calculus too where you need to complete, especially when you get to conic sections. Anyhow, this is why it works. Now let's see how it works out. This tells us then that x squared plus 10x is the first part of x plus 5 squared, meaning that this is the first part of this if h happens to equal 5. But of course, x plus 5 squared doesn't equal this. X plus 5 squared has that 25 in it. Okay. Well, that means that x plus 5 squared minus 25 does equal x squared plus 10x. Subtract that 25 and you get this. Okay. Because x plus 5 squared minus 25 is just this, the x squared plus 10x plus 25 minus 25, and that does equal x squared plus 10x. So we conclude that x squared plus 10x is the square of x plus 5 minus 25. And you always check that, just expand this and simplify it, you're going to get x squared plus 10x. Now, we've then extended this problem, okay? This answers the question as it's posed, but why would we want to do this? Well, if you want to graph x squared plus 10x, you figure out what x squared plus 10x is equal to in this form. And what's this form tell you? This form tells you that you have the x squared graph shifted 5 units to the left and down 25 units. Now, that's assuming you understand the rules for transformations, hopefully even the reasons for those rules, okay? Now, this shifts it to the left 5 units because x has got to be 5 units less to give you the same value as x squared, okay? And then minus 25, well, this is your y value of x plus 5 squared, okay? If you subtract 25, your y value goes down 25 units, so the points go down 25 units. And in any case, the rules for transformations, or hopefully even more deeply understanding transformations, tells you that the graph of this is a graph of your basic x squared function shifted 5 units left, 25 units down. So if this is a graph of the basic x squared function, you shift it 5 units to the left and get x equals -5 for your axis of symmetry. Make sure that makes it more visible. Okay. X equals -5, axis of symmetry. Then take this and shift it over here, your vertex goes here. Then you shift it down 25, your vertex goes here, and there's a graph of the same shape as your x squared graph. And incidentally, this graph also goes through the point 0, 0. So the shape of these two graphs just, I kind of estimated it right. They kind of match. Okay. That's unusual that I estimated it right, but I did make an attempt. Okay. In other words, if x equals 0, this is equal to 0. So the graph of this thing has to go through the point 0, 0. So here's your graph of y equals x squared. And here's your graph of y equals x minus 5 squared minus 25, which is, of course, x squared plus 10x. Okay, you got a question, but pause here. Get that? Wonderful question. What's the domain and range of this function? Okay. Well, kind of do that down here. The domain is unrestricted because there's no value of x that can't be plugged in here, no matter how big positive or negative. It works, okay? So the domain would be all real numbers. The domain is unrestricted. There's no reason to eliminate any x's. It's not like there's a square root of some expression or a reciprocal. It can't be equal to, denominator can't be 0. No denominators, no square roots, no other little twists. And if any value of x can be squared, multiplied by 10, and the two numbers can be added, okay? The range, well, the lowest number you can get is what? What's the lowest y value? It's 25, -25, right? Okay. Y values less than -25 don't occur. Okay. Clearly, this parabola keeps going up forever, right? In other words, no matter how big y is, you can find an x that gives you that y. Okay? Because there's no limit to how big x squared plus 10x can be. There's no limit to how big y can be. Now, there are more formal ways to work out that range, but right now we'll just go with the graphical picture, and we can see that the range is the interval -25 to infinity. Okay. So we could say, see if I can write an infinity to slow on the board. As x goes to infinity, y goes to infinity. Okay. So without writing a lot more words, I'll just wave my hands and say, it doesn't take much hand waving to see if the range goes from -25 to infinity, including -25. Okay. That's number 11. Okay, number 11. Now, number 11 says do the basic exponential function. I did that in another class, and I'll post that. And if I happen not to post it, email me to prompt me to post. It takes a minute. Got back from the meeting and stuff this afternoon. I'm not sure I'll remember or even look at a note if I write one. Okay, so -2, -8. Of course, I table, and I put -1/4 here because I wasn't thinking. So don't do this without thinking. That's 1/8, -1/8, 1/8. Okay, -2, -8. Going to be here. -1, -1. Well, here's -8, -4, -2. Here's -1. Here's -1. You have this part. And then -1/2, -1/8. Now, when you draw this graph, if you want it to be halfway accurate, you're going to be pretty careful about this -1/8. Some people put it like here. Well, that's about -1/2. That's not -1/8. And they get a distorted graph. And 1/8 is, here's -1. So here's -1/2. And halfway between that and the x-axis is -1/4. And -1/8 is really close to the x-axis. Okay? This is -1, divide that into 8 parts, you're going to put a point that's practically on the x-axis. Then here you get 0. Here you get 1/8, again close to the x-axis. Here you get 1, and here you get 8. Okay. So first of all, let's do this in blue. Okay, there's the graph of what I call the basic function. It just consists of the 7 points that you get from the table. Now, in text, in materials, I might say that the basic function is the whole thing from -infinity to infinity. Well, you can't handle that. Okay? Nobody can handle that. Some people can handle it better than others. Where's my green chalk? What y'all do with my green chalk? There it is. Okay. Stop doing it. Okay, I know. Okay, so we can connect these points starting here. And ending here. So include this point. I include this point. And now we have a graph on the domain -2 to 2. Okay? So the domain of the blue graph, which just consists of 7 points, is just all your x values. And the range is -8, -1, -1/8, 0. I would have 8 in here because that's hard to write down the little part of the board. Anyhow, it's all your y values. Okay, that's at least reasonable. There's your range, okay? Now, if we connect the thing with the blue curve, or the green curve, the domain is the interval -2 to 2. And the range is the whole interval because there's nothing excluded here. You can cube any number, okay? Just everything from -8 to 8. Easy enough. Now, if you want the whole function, well, the whole function can be defined for any real number. So you can cube any real number, so your domain of the entire function, which is what your book or your materials, whatever you want to call it, talks about, is all real numbers. And your range would be all real numbers, because if you can go, further you go in the negative direction, the steeper this gets, you get through a lot of negative numbers really fast, right? And as x goes to negative infinity, clearly this thing gets steeper and steeper. It goes to negative infinity. Okay? And as x goes to positive infinity, it goes to positive infinity. Okay? So you pick any number, no matter how big. You can find a number that you can cube that will give you something bigger. In other words, x is always big enough to be at least as big as any y that you might choose. That's kind of an important statement, okay? If you get into calculus and do limits and stuff like that, that's fairly close to the formal definition of a limit. You don't need to know that right now. Basically what your materials tell you and what I've told you, that's a good start, okay? But I also want to give you a little feel for what it goes for. Okay, so there's your graph of y equals x cubed. Now, I got to look at the problem, see what the next question is, but I think it's okay. So I'm just going to make up my own question. The question I've got there is probably more attuned to the exponential function than it is to this function. So let's say, I'm going to say, let's estimate f of 3/2. And then estimate the solution of f of x equals 4. Okay. I'm going to talk about that a little bit and see what that might mean. Okay, so my drawing isn't great. Okay, it didn't get flat enough, right? Your drawings were even worse. So I kind of asked you to correct them. They really need to flatten out. Mine didn't flatten out well enough. Okay, so I'm not going to get great estimates off of this graph. But I just said slop one down because I don't necessarily care that much if you get a really accurate estimate. I just want you to see what the estimation process is like. All right, so I'm going to erase this because we don't need it. I've got a good graph here. So my estimates are going to be better than yours. But now, how would you estimate f of 3/2 based on your graph? Okay, we're trying to estimate f of 3/2. Now, the function is, of course, y equals f of x equals x cubed, right? So f of 3/2 would be 3/2 cubed. Now we can figure that out. It's 27/8, which is 3 3/8. Okay, but that's cheating. I don't care if you cheat, as long as you show me on the graph how you would have done it if you hadn't cheated. Okay, and you can't always calculate it. Okay, if it's e to the 3/2, good luck, or 2 to the 3/2. You're not going to be able to calculate it. So you might want to get that one. Okay, f of 3/2. Okay, so let's write out a little reasoning here. Okay, estimate f of 3 halves means, well, f of 3 halves would be a y value, right? Because f gives you the y value and f applies to x. So it means x is going to be 3 halves and you want to find the y value. Okay, well, that's really pretty easy to do if you got a good graph. I don't know how my estimate's going to come out. I'll try to make an honest one. I mean, here's 1 and here's 2. So here is x equals 3 halves, okay? Now, I want to find the graph point that corresponds to x equals 3 halves, because that's going to tell me what the y value would be. Well, x equals 3 halves here, and x also equals 3 halves. Everywhere on this vertical line, right? Now, where on the graph does x equals 3 halves? Does x equal 3 halves? Well, x equals 3 halves at this point on the graph. Okay. So what's the y coordinate of this point? That went downhill a little bit. What's it look like? F of 3 halves is the y value of the point on this graph when x equals 3 halves. What's that y value look like? Show me with your fingers. Yeah. Yeah. Hold your fingers like this. I don't know how many you got up. I had somebody else sitting there, who's a really good guy, really, and you know, a really good student in a different course. And he's sitting there holding up 3 fingers like this behind the brim of his baseball cap. I said, hey, Joe Bob. That's not his name. Perfectly good. Joe Bob is a perfectly good name. I had an uncle named Joe Bob, one of the best people you know. Okay, anyhow, f of 3 halves. Certainly looks like it's about 3, right? According to my graph. Now, this thing went a little downhill. It should probably be a little more than 3, but that's what came out when I tried to do it right. Okay. And it really should be 3 3/8. It really should be up just a little bit higher than that. Now, even if I'd have made this perfectly horizontal, it wouldn't have gone up high enough to make a really good estimate, reasonable estimate. Okay. If you cube 3 halves, you're going to get 3.375 or 27/8. Okay. 3 3/8. So we've got a pretty good estimate. Now, I asked you to estimate the solution of f of x equals 4. And I no longer want you to do that because the projection lines and the point are going to be pretty close to this one. So I'm going to change the number a little bit. Wasn't thinking ahead. I chose x equals 4. Of course, that differs from what's in your, what's on your sheet, but it's the same idea. So let's try f of x equals, what's my number? Let's try, I don't want to do that. Okay, we're going to do f of x equals 7. Okay. So where on the graph would you find the point that tells you what's the solution of this equation? Okay. Now, of course, I'll say f of x equals 7. What's f of x? F of x is x cubed. In this case, it's a different function, of course, 2 to the x or 1 over x or whatever. Okay. X cubed equals 7. Now you can solve that. You can take the cube root of both sides, punch it into your calculator. Okay. And we might do that. But according to the graph, what would the solution be? How can you use the graph to find a solution to that equation? Okay. What's your reasoning for f of x equals 7? Well, you want to find the x that corresponds to 7. What's 7? 7's a y value, right? Because f of x gives you y values. So f of x is a y value. The y value is 7. So we want to find the graph point or points, because there could be more than one, not in this case, but this is a one-to-one function for y equals 7, right? Once you see that you're trying to find the x value that makes y 7, you go to your graph and say, okay, well, let's see, where's y equals 7? The y-axis is here. Let's see, y equals 7 isn't down here because those are negative numbers. Okay, well, y equals 7 is between 4 and 8. We can do a little more with subdividing the y-axis. We get 6 here, halfway between 4 and 8, and then we get 7 halfway between 6 and 8, right? So then we can draw all the points for y equals 7. So here's the y equals 7 line. Here's the y equals 7 point on the graph. What's the x coordinate? Well, show me the y equals 7 point on your graph and estimate what the x coordinate is. Just want to give you a minute. I think maybe you can do this in a minute, at least think a lot of it through. Okay, only got 5 minutes left, so let's get to this. Okay, well, that point looks like it's almost under this point, right? So if I sketch down from this point, it's going to give us something pretty close to 2. So here's 1 and here's 2. Now, Colton, what do you think that is? It looks like 1.8 or 1.9. Which one do you think? Huh? Okay, 1.9. Okay, now somebody else got 1.8. Okay. Now, if we had a little more time, I'd let you two fight it out. But they're both good estimates. Okay. And it's hard to get a good estimate because the graph is getting almost vertical here. Okay. You know that number is going to be pretty close to 2. Okay, well, you could cube 1.8, which would be 1.8 times 3.24. 2 times 2.24 would be 6.48, okay, which almost rounds to 7. So 1.8 isn't a bad estimate, okay? But it's probably going to be a little more than 1.8, okay? However, 1.9 gets you much closer to 7. So neither one is a great estimate. It's somewhere in between, okay? Yeah, take a calculator and cube 1.9, take a calculator, cube 1.8, okay? You're going to get some results that show you that you pretty much have equally good estimates, okay? And that's x equals 1.99, not y equals 1.9. So right there's your answer. And here's your construction, okay? Article 7 line, take you over, brings you down here. You want to remember why this is true, otherwise you're going to get them mixed up. Got to remember, you got to know that if you're doing f of something, then that something is your x, okay? And then your f of x is your y, okay? You can memorize, okay, when I see this, I project this way, and when I see this, I project this way. Or you can understand what it means so that you can really get yourself mixed up, okay? Or hopefully keep it straight. And go ahead and memorize. If it's this, you do this. If it's this, you do this. But also try to learn why. Because if you learn why, you can always reason it out. Okay. Bottom line, got a file coming up, do what works. But I always advocate, understand it as deeply as you reasonably can. Okay. And then focus on what works. Okay, well, addressing people who aren't here as well as people who are here. The people who've stuck with the course have done a really good job. Missing the people who haven't. And some of the people who aren't here today aren't here because they really don't need to be, because they're already on track to make a good grade in their pre-calculus and don't really feel the need for a lot more preparation in here, okay? And I think I agree in at least a couple of cases, people are in that shape, okay? So thank you all for sticking with it. Enjoyed having you in class. And maybe run into you in another class sometime in the near future, but if you run into me, tell me how you're doing, okay? Keep me posted.